By now you must be familiar with the definition of a quadratic equation and its standard form. So if you see an equation, you should be able to tell if it is or isn't a quadratic equation. For example, consider this equation. 5x squared plus 6x plus 40 is equal to 0. The equation has only one variable, x, and the highest degree of the equation is 2. So this equation is a quadratic equation. If we think about the standard form of a quadratic equation, we'll realize that this equation is already in the standard form, which is ax squared plus bx plus c is equal to 0. Here, a is equal to 5, b is equal to 6, and c is equal to 40. This was a simple and straightforward example of a quadratic equation. But there are some equations which don't really look like quadratic equations. Consider this equation. X plus 6 multiplied by x plus 5 is equal to 0. What is the degree of the equation here? Is it 1 or is it 2 or something else altogether? At first, it might seem like the degree of this equation is 1 because the power of x at both places is 1, right? But let's expand this equation first. If we simplify it, we get this. Now what do you think? What is the degree of the equation? Yes, the degree of the equation is 2. So the equation we arrived at is a quadratic equation. Now let's take a look at an equation that only looks like a quadratic equation but is actually not. Take a look at this equation. X plus 3 multiplied by x minus 7 is equal to x squared plus 8. If we simplify this equation, we get this. Is this a quadratic equation? What is the degree of the equation here? Looks like it should be 2, right? Because there is an x squared term in the equation. But no, the degree here is not 2. Let's simplify the equation further. One x squared term gets cancelled by the other x squared term. So the equation simplifies to this. What's the degree now? Yes, it's just 1. So is this a quadratic equation? No. Hope you understood why. Let's recap what we've learned so far. Some equations are easy to identify as quadratic equations. You can tell just by looking at them if they are quadratic or not. There are equations which might not seem like quadratic equations at first, but when we simplify them, they turn out to be quadratic equations. And finally, we learned that an equation might look like a quadratic equation, but when simplified, we find that it is actually not. So sometimes we might need to simplify equations to verify if they are quadratic in nature or not. The next time someone asks you if a given equation is quadratic in nature or not, you know what to do. I'll see you soon.